Bill, thanks for jumping on the podcast today. You just released the results from a really in-depth study that you had done with the University of Colorado about arrows, flight, vanes, drag, and why don't you go ahead and give the listeners a brief background about the study, what you were trying to find out, and what methods you used to get that data?
Yeah, yeah. Thanks, Garrett. Thanks for having me on. So the reason I did this study is, I'm the owner chief engineer at Iron Will Outfitters, so we make broadheads, of course, and I just saw a lot of information out there that wasn't quite that accurate, or it applied to target archery, but not necessarily bow hunting arrow setups. And I'd done a lot of testing myself, but I really felt like I really wanted an independent university study that really dug into arrow flight with broadheads on the front and really applied the science and did scientific, modeling as well as empirical testing, controlled experimental testing. So you can, say if one thing's better or another statistically. And I really could kind of foresee that there's a lot of information missing here that I think would be beneficial to have. Also, I've been an adjunct instructor of mechanical engineering for several years at the University of Colorado as one of the faculty directors for the senior design project class. So, after talking to them for about a couple of years about it, I got it approved to, sponsor and direct projects for this one specifically was, improved arrow vanes for flight, an arrow with a broadhead on it, hunting arrow, like improving hunting arrow flight, basically. And a lot of it was looking at the vane design itself. And, included a lot of, so there's a lot of, CAD modeling. We modeled up several of what I felt were probably some of the top art industry vanes today. Did fluid dynamic modeling. We did it with a complete arrow with both field point and broadhead on the front with the vanes at, we did it at 3 degrees and 2 degrees. Helical. We looked at drag, spin up, restoring torque, which is, we tipped, we looked at drag with the arrow straight into the oncoming, airflow, but also we would tip it at 5 degrees and look at how much restoring torque is there, or how much side force is there from those vanes that are going to pull it quickly back in line. That's a great measure of accuracy from my past testing. Is how much it's going to, restore, get it right back on track, pointing straight down, down target again. So, so kind of accuracy, stability went together, but then drag and wind drift, which kind of also go together, spin up and sound. So we did some modeling for that, fluid dynamic modeling, and then used a shooting machine with lab radar, microphones downrange that we'd shoot over. High-speed camera that we could look at the spin up and look at kind of the stabilizing there. Yeah, and then we measured accuracy, and we take a bow out of tune, and we'd quantify that by shooting, bare shaft versus fletch shaft at 40 yards with a little weight added on the back of the bare shaft. And and this is a great test for everybody to do to see how well their bow is tuned. But if your fletch shaft just with field points, if the fletch shaft's hitting the bullseye and your bare shaft's hitting 6 inches right, and if you shoot in just kind of a flat foam target, you can also kind of see the angle of the arrow. If the arrow comes out, say tail left, it's just going to go downrange and stay tail left and then impact right. And so we use that to quantify how bad is the bow out of tune. And to me, in my other testing I've done, if you're within, say, 4 inches, you're good enough. That's a pretty good tune. A lot of the testing we did was in like the 8-inch range, 6 to 8 inch range of the bow being out of tune. And then we could look at where did field point hits versus broadheads with each different vane. And that we'd use that to quantify kind of stability and accuracy with those. So it was actually, we've spent 2 years at this. The first year was a lot of benchmarking industry vanes, understanding why they were doing what they were doing, and picking what was the most accurate vane, really. And the hybrid, that hunter profile, looked very good in the modeling and the testing. And then we tested in 3 different materials: a very flexible material, then the hybrid material, and then the max material. And the hybrid material in last year's study ended up being the most accurate. So that was mainly last year's study. This year, we spent a lot more time with different vane profiles and trying to understand what was causing sound or drag and stability, and really did, I don't know, 50 different profiles, just a lot of different profiles, narrowed down and continued the testing. But we're just finishing up that second year at this point.
Okay. And I would imagine when you're talking about, say, stability, for instance, in a perfect world, you would have that shooting machine, you could shoot, your fletch shaft hits center, your bear shaft hits 8 inches right, so you're out of tune. You put fletching on, shoot a broadhead, and it hits right with your field point, not with the bear shaft. That'd be an indicator that you had a well-stabilized vane for that broadhead, right?
Yeah, exactly. And that's what we see with the best performing vanes. A broadhead with the bow that far out of tune, the broadheads are still hitting, within an inch of field points at that distance. The vanes that don't perform it as well, they might be 4 inches off at 40 yards. And I could tell you, in general, height matters quite a bit. The vanes that are taller, that 0.55, 0.58 inch, that's kind of the highest, the tallest vanes in the industry are kind of at that range. They just perform better than ones that are 0.45 or something like that. And some companies have said, they've made a vane that's now shorter and longer. It'll be quieter, but have the same stability because it has the same surface area. We don't really see that to be true. It's not true in the modeling. It's not true in the empirical testing. So, but I hear that all the time out there. I think a lot of people have just gone along with, kind of industry talk of vanes. Like, oh yeah, I used to shoot high profile vanes, but now I've gone to a shorter vane, a little longer. It's quieter, but still stabilizes good. Well, it doesn't really stabilize as well. So that's one thing, that there's 3 reports that we just published. And one of them speaks to vane height specifically, as well as vane shape. But that's kind of a key takeaway, is that, shorter vanes don't work as well. And they can be a little quieter. It's a fairly small percent. I think, if I have the numbers right, I think going from 0.58 down to 0.53, we had 2.5% less drag, like 4% reduction in sound, but 11% reduction in restoring torque, so accuracy.
I got it pulled up here, and those numbers are pretty close. And I remember reading that because I read these, before we jumped on. And yeah, 11% decrease in restoring torque, 2.5% decrease in drag. And so if you were asking somebody, hey, would you like a quieter vane? Like, well, sure. Okay.
Yeah.
What if that came at a 2% benefit to sound and an 11%, detriment to your stability? And a lot of people are like, I don't know if that's worth that juice is worth the squeeze, right?
Yeah. And that's really, that sums up a lot of why I want to do the study is give the data there, give the numbers there, because it's thrown out so much. And I can tell you, even though I've given the numbers, there's still a lot of people that are like, oh, I want a quiet vane, and I'm not going to shoot a tall vane because it's too loud. I can tell you that, we did a post on Instagram last night just on vane height, and we got 40 comments back. It's a hot topic. People are pretty hot on this. Like, I can't go tall. It's going to be loud. It's a little bit louder in general. And this year I could say that we figured out how to make it quieter, but my personal opinion is still, I would 100% take accuracy over sound when we're talking about a pretty small difference in sound. And really I was just looking at the data recently, we're shooting bear shafts too and measuring sound. So, I can roughly say that, a bear shaft being, say, 40 decibels, the quietest vane being, say, 42, 43, and the loudest vane being 45, 46 decibels. So it's, the bear shaft might be a little bit lower than that, might be more like 38. But if all you care about is sound, shoot a bear shaft, right? Just go shoot a bear shaft. All you care about sound. Why don't you want to do that? Because your accuracy is going to be terrible, right? It's going to be, well, it's going to be very unforgiving, right? At close range, it could probably still work, but any distance to it, anything that's going to create some angle of attack, it's going to be unstable. So who knows where it's going to hit? But just apply that, I prefer people have that line of thinking, like instability, poor accuracy is bad, and we want to have as good accuracy as possible. So that'd be my argument for a taller vane over a shorter vane, even though it's a little bit louder. So
yeah, that's interesting, and obviously there's trade-offs all throughout archery. And when I had done some sound testing with my bow, everything apples to apples, and then compared it against my wife's bow, which is 40 pounds, 25-inch draw, at pretty much any arrow weight out of any of those bows, any speed, any vane style, her bow was, we're talking 5-6 decibels quieter than mine. And I was shooting what, many would compare or would say would be one of the quietest bows in the market. But I think if you have this little bit of, available energy, and that it seemed like me shooting 75 pounds at my draw length, there's just a lot more to start with. And so whatever residual either through the bow and or the arrow gets translated into sound. And again, if you tell people, hey, if you shoot a 30-pound bow, your whole setup is going to be way quieter, they're probably not going to be willing to make that trade-off to lose everything else that they had going with their normal setup.
Right. Yeah, and I can tell you that I'm working on making a quieter vane, just because I think there's such a perception out there it's needed. I mean, I don't think it's a bad thing, certainly, but personally, I wouldn't give up accuracy for a little difference in sound. Now, I would say that there's some that are screamers that buzz, and you don't want that. And that's what we saw with too flexible of a vane. We tested some very flexible materials, and in the high-speed video, you can literally see the vane, fluttering in flight, and those would just buzz. But I'd say any of the industry vanes, there's a couple that are very tall, very short in length, that are pretty loud. Anything that goes, very abruptly up and then is high can be pretty loud. But, most of the vanes you might pick out there as a common hunting vane, they're just not that loud. Not so much over others, and I know people are going to argue that, but that's kind of my opinion on it. I choose accuracy over those little differences in sound personally.
Yeah. And I guess I'm curious too, number one, how that sound testing was done, because I've tried a number of times to do sound testing, and I can shoot the same set of tests with 3 different microphones, and they all perceive to be either like, oh, there's no difference, or like one vane profile sounds better with a certain microphone, but it sounds worse with a different microphone. And you were throwing out some decibel numbers too. I'm kind of curious, what was your test setup like? Maybe it's something I can adopt when I do my own testing.
Yeah, I can get you the specs on the equipment, but it's a sound recorder that has 2, omnidirectional microphones in the sound recorder, and we have it, downrange, and we're shooting over it, and we'll capture the whole trace then from the bow. What we see is the bow shoots, and then there's this ringing from the bow. The arrow is probably 10 yards downrange before the ringing from the bow stops. And then, the arrow's relatively quiet, and then you get this flare up, just that last couple of yards, you get this flare up, and kind of a bell-shaped curve of that noise as it goes past the microphones. And we're the way we're analyzing it is we're finding that peak, and then going back, I believe it's 0.3 seconds, or 0.03 seconds. Yeah, 0.03 seconds. So we're trying to get, just the loudest part of the vane, and get that area there. And I can give you the report that shows all the setup for sound in detail of like how, all the settings we used, and how it was analyzed, how we use MATLAB to bring it in and look at frequency content and things like that. But I was having, like last year, I had the students also look at it about 10 yards from the impact, like what would the animal hear when it's 10 yards away. my thinking there is that that's about when they'd have to hear something and if they're going to react to it. I think in competitive racing, sprinting, if you move within a tenth of a second of the gun going off, they say that's you jump the gun, because they've determined a human can't hear a noise and run in less than 0.15 seconds. So if you move within 0.1, you're disqualified. Let's just say an animal can move that fast, 0.1. That's when the arrow's about 10 yards away. He'd have to hear that louder noise that would make him move, right? And really, when we analyzed all these different vanes 10 yards from impact, we couldn't get a statistically significant difference between any of the vanes, the loudest to the quietest. So that's more of my thinking of why sound doesn't matter as much as people think it does. Now, we could get a difference right at impact or those last couple of yards, but that's a couple hundred milliseconds. Really, it's a very, when that arrow's a yard or two from hitting them, and it gets loud, then it's too late. I mean, you could argue that, well, they're going to react more when they hear that sound or run further. I might buy that, but I don't really buy that they have enough time to jump the string basically, or duck the arrow because of vane noise differences. That's gonna be argued out there. There's a lot of pros and things that will argue differently, but that's kind of what. And I come into these things I try to be very open-minded. As an engineer, you try not to have any preconceived motion and try and prove it out. What you try to do is just like look at the data and what conclusions does that lead you to? That's currently my conclusion. Is I don't think it matters as much as most people do out there.
Yeah. My personal bias is they're either going to jump the string or they're not, depending on a variety of factors, which includes their own, personal temperament and behavior at the moment of the shot. And once the arrow's released, the only thing that's going to change the point of impact could be, the arrow speed, because there's a time to target, and that's all easily, you're able to calculate that. On the vane height thing, before we jump off of that and move on to the next topic, one thing that I've seen it on my last bow, in fact, that I had to 3D print a new rest containment cage. Sometimes those high profile vanes, there could be clearance issues either with bow cables on certain bow designs or rest containment arms, maybe the rest itself. And would you say in that situation, if somebody's getting contact with a high profile vane, would they be better off then going with a lower profile vane and maybe adding a fourth vane, or just trying to figure it out on the rest side of things and stay with that 3 high profile vane tried and true?
Yeah, that's a good question. It is something to point out with people. Just go to a higher profile vane. You got to make sure you don't have vane clearance issues, impacts. Yeah, impacts are bad. If your vane's really flexible, I've had impact issues with a vane or a rest rebounding that I didn't realize. And with the flexible vanes, I still hit well at 100 yards, but a stiffer vane, it was kicking it off, and that's actually how I figured it out. But yeah, I mean, that's got to be. Yeah, got to get rid of that. That's bad. So I've, in my my bow setups and my rests that I've tested, for several years, I haven't had a vane clearance issue that I couldn't solve by, rotating it around or doing something like that. But yeah, if you can't, then you would be better off with shorter vanes. The shorter vanes, more of them, is a good question. I think so. Like, a common setup is 4 max stealth vanes at 0.5 inches high, or hybrid 2.6. It's the same vane with the hybrid material. I think that's a pretty good setup. It doesn't, for me, it hits about 1.5 feet lower at 100 yards than 3 hybrid hunter. It's got more drag. So the penalty of that fourth vane is you're adding more drag, and drag is just that inline when the arrow is going directly into the wind. How much force is there pushing back on it? So that extra vane, more surface area, you add drag. It does add some restoring torque too. So when you tip at some angle of attack to it, that fourth vane does add some, but proportionally it's not as much as the drag that it adds. So to answer your question, I think yes, it can make you shoot more accurately, give you more restoring torque. The penalty is more drag. If you're not really a long range shooter, so more drag can give you, a lower drop and more wind drift. But if you're not shooting very far, if you're like whitetail hunter shooting 40 yards and under, for sure, there's no real penalty to it, even at 50. So I think it's a good setup. If you're happy with that, it's been shooting well for you, stabilizing your broadheads well, I wouldn't talk you out of it. I just try to go for, what's the ultimate, setup as a Western big game hunter. I want to be able to shoot elk, deer, whatever, at 60 to 80 yards very accurately, in wind, whatever. So I try to kind of optimize everything. And to me, like 3 higher profile is a bit more efficient in doing everything than the 4 Vane, slightly shorter. But I think 4 Vane slightly shorter can work too.
Okay. And I guess this may be a good point to make a definition. When we talk about something that's restoring torque, some people might hear that and think that that's the torque that's the vanes are imparting to cause the arrow to twist. But you're talking about, we have this arrow and it gets slightly off, and it's that torque that's pushing that arrow back to center, correct?
Yeah, correct. Yeah, we should really talk or touch on that, because I've just seen a couple of videos and podcasts recently where people are talking about one vane works better than another because it stabilizes faster, and they're equating that with spins up faster. So spin isn't stability, or spin doesn't really stabilize the arrow. It's important, but it's different. And spinning very fast isn't necessarily better than spinning up moderately fast, in my opinion. And we can get into what spin does here in a minute, but yeah. So when I talk about restoring torque, it's probably not commonly talked about out there, but what I mean is, if your arrow is not coming off your bow perfectly straight, let's say, and I'm just going to do it up because it's easier to see, but if your point is tipped up or your tail low coming out of your bow, let's say a little out of tune, that's happening. Well, the airflow across the broadhead blades is going to create this lift force. So lift, drag is a force in line with the wind. Lift is a force perpendicular wind. It's not necessarily up or down, right or left. It's just perpendicular. So you get this force up on the head, this lift, and that's going to want to push it off course. And if you say the center of, your balance point here, the center of mass, you can kind of sum the torques about the center of mass. So this force here times this distance is going to create some torque that's going to push it off course. At the other end, the airflow across the vanes here is going to create also lift, pushing the vanes up. That's going to restore your arrow back to going straight. This force on the vanes times that lever arm to the center of mass is going to create that torque. So the restoring torque in this study is we sum those two. We sum the torques about the center of mass, and you want a vane that's going to have a higher restoring torque because that'll make it more quickly get back, back on track, back in a straight line. So, as long as we're talking about this, so increasing your FOC, having higher FOC or moving your center mass forward can create a longer lever arm to the vanes, shorter lever arm to the broadhead. So that's really the reason for me to not go really low FOC, like 10% and below. I don't really recommend with broadheads as I talk to customers. I think you're reducing your stability quite a bit. I'm not an extreme FOC guy because I think it's not a huge difference to go from 15 to 20% FOC, but a lot of other issues often come up with trying to go that high with, at least for me in a long range shooter, arrow mass. Are you cheating on spine? Are you now weak because you're going that heavy? So I'm not an extreme FOC guy, but I like a moderate FOC. A lot of my setups are 12 to 16%. But a little more FOC can help you be a bit more stable. So, that's good we touch on that, because I think that restoring torque is probably confusing what that means. Any more questions on that? Otherwise, I should probably touch on spin here too. Maybe.
Yes, one quick question before we jump off the FOC thing. I've heard from a number of people who've said something to the effect of, if I go too high and maybe have too big of a vane, then they get more fishtailing. So is there a certain point where maybe this restoring torque is causing an overcorrection? And I mean, thinking through the force diagrams, it doesn't seem like that would happen. But like, what would cause the fishtailing that you might see in the wind with, let's say, a really high FOC arrow with a large static margin, and you just get that back and forth more so than you would get with a more moderate front of center?
Yeah. So a higher FOC, it will track closer to the direction of the wind, and react faster to it. I don't really see that as a negative. I think, if you're shooting into a crosswind, a higher FOC is going to more quickly align with that wind. And that might be what people see. A lower FOC and shorter vanes will take longer it'll get pushed to the side more. But it'll also take longer to align to that airflow. And so if there's wind gusts, if you're shooting through an area, and I've done this a number of times in the mountains where I'm at, it's not windy, where the elk's at, it's not windy, but in between it's windy. And I'll see that. It'll come out of my bow, it'll kick the arrow a bit, it'll be at an angle, and it'll go straight again as it hits the elk. And so the higher FOC will more quickly react to those changes, but I don't think that's a bad thing, really, because if it's more slowly reacting and aligning, you're getting more side push you're getting more drag from that whole arrow. And the reason that's bad is, so if your arrow is straight in line with the wind, let's say the drag is 100, just to say a unitless number. If you're now tipped at 5 degrees to the wind, that drag is now much higher. It's like 30%, 50% higher. So to me, quickly aligning with that resultant oncoming wind, and when I say resultant, it's like your arrow's going maybe 285, you got some crosswind 15 to 20 miles an hour, your arrow's going to tip at, say, 5 degrees into that resultant airflow direction. And then just that inline drag is going to slow it down as it gets there. And it's going to have this inline drag is going to have some cross component to it, which will create that, distance equals 1/2 AT squared. It's going to create that wind drift over that distance. So,
yeah.
Anyway, that's why I think, yes, it will react quicker to changes in airflow, but I don't necessarily think that's a bad thing. I think it's maybe something people are making up that have really heavy arrows, or want to justify heavy arrows. I think they will react slower, but I can't see. They could argue that heavy is better for less wind drift, but I think you're still better off with a higher FOC heavy arrow in that case.
In terms of angle of impact, assuming, to get to a higher FOC, somebody went with a heavier arrow that is now flying slower out of the same setup. If it's flying slower forward and the wind speed is still the same, then that results in airflow is more tipped, right? So would that arrow align to be more, at an angle to the impact site than if you're shooting a faster arrow that's comparatively stronger compared to the crosswind?
Yeah, that's what the math would show. If you got a higher, for a given crosswind, if you've got a lower bow speed or arrow speed, it would create more of an angle to it. It's going to be small, probably practically it's going to be small. I think if you went from like 280 to 300 feet per second, I think I figured out it'd be a less than a degree type difference. But that would be true. I think if wind drift is your concern, I think there's been studies. Dr. James Parks from Australia has a PhD in mechanical engineering, has put out books and articles on arrow flight. A lot of his is all target archery, but I connected with him and I've been communicating with him throughout the study, getting his thoughts, because he's done a lot of shooting machine studies as well. And then send him these 3 reports also for a peer review, because the conclusions are different than his in target archery, frankly. But that's why I wanted to review. But he agrees with the conclusions. Yeah, when there's a broadhead on the front, things are different. And target archery is really all about, trying to hit as close accurately as you can at long range. So having, a taller vane, if I was just doing target archery, I'd try to go as short a vane as I could, reduce that drag, go faster. Well, if it's, and it would really vary. My setup would vary. If it's unmarked target archery, then I want it as fast as possible. So any yardage estimation is taken out. So, but if it's, say, known distance but long range outdoors, which is what Dr. James Parks was often doing, then it's a really heavy micro diameter, really heavy arrow to reduce wind drift. But then the distance is known, so it doesn't really, the speed isn't as important there. So, really for each of your setups, the answer is different. For hunting though, I think you want to, hit accurately with a broadhead that's going to have a low force to penetrate, through hide bone tissue. Personally, I think that's, a fixed blade broadhead, very durable, cut on contact. It's going to get you through all that. But then an arrow setup that's going to make you be able to shoot that accurately, have the arrow going straight at impact, have the momentum in a straight line. So other things that come to mind there are having a too flexible or a underspined arrow doesn't often hurt you very much in target archery. In fact, Dr. James Parks said that his spine studies didn't affect accuracy very much at all. But in bow hunting, you really don't want an arrow. And that's the problem I see with guys with going to extreme FOC. I see some videos where their arrow's doing this. And at impact, you don't want that. You don't want your arrow doing, bending a lot. You want it to be straight in line. So anyways, I'm all about what's the best arrow setup for bow hunting for, effectiveness on animals.
Yeah, I've always kind of, well, not always, but recently I've kind of been thinking, if I had to choose between wind drift and angle of impact, I'd rather have it move a little bit more and hit straighter than have it hit right exactly where I wanted to, but at, a 10-degree angle of impact, which for target archery is the opposite. You don't care how it hits the target. You just care how close it is to the center.
Yeah, I think even if you had lower FOC, it's taken longer to react, but I believe it's still going to be at that resultant angle, when you're done. I think there's always an angle of attack in the vertical as well, because gravity is pulling you down. So your trajectory is arcing down, even though your arrow just would want to keep going straight. So there's always a little bit of angle of attack there, and you can see that I've seen that with lower FOC arrows, that they drop less, because they're getting a little bit of lift out there. But yeah, so effectively that gives you a little bit of angle difference between the trajectory impact and your arrow going in. But I think these are small. I think those are small angular differences.
Okay. You touched on spine too. I guess I've gone down the train of thought of even if my spine chart says 300, I'll do a 250 and cut it as short as I can, for the same reason that you said it's going to flex less potentially on impact or even hit straighter. And frankly, I can't shoot the difference probably with a broadhead on it between a 250 and a 300 spine. What are your thoughts on that? Can you go too stiff?
Yeah, I would agree with you in general that stiffer is probably better for bow hunting. And there's an argument, can you go too stiff? I think, well, if you think about it in terms of, say, like a recurve, where they're not cut to center and you've got an arrow, you want it to go straight, but it's pointing to the left because it's not, cut to center, or a longbow or a recurve. So then you need some optimal spine, some kind of perfect stiffness to make that thing, bend around your riser and end up going straight. It's gonna flex a lot, but it's gonna kind of go straighter downrange if it's at some optimal spine. So if you go stiffer there, it's gonna just fly off to the left. Weaker, it's gonna fly off to the right. And there's some perfect spine. If you think about your compound bow, if it's perfectly tuned in that your knock's pushing directly in line with your rest, I think you could argue that you can't really hardly go too stiff. And that's a lot of my thinking is that I want to try and get that tuned as well as I can, and then make sure my arrow's optimally to a little too stiff, because it minimizes the flex. And if I'm like optimal, and we have arrow charts on our website for different total weight up front from 125, 150, 175, 200, and we've modeled each of those boxes in there. And so those are kind of, nothing's on the weak side. Everything's optimal to a bit stiff. And, with that, what I see is I get maybe like a 1/2 inch vertical flex or less coming out of the bow. And then it's kind of gone, within, 6-10 feet. So minimal flex. My arrow's going very straight, when it impacts target. So that's personally what I think is better for bow hunting, is to be optimal to stiff. Being one spine stiff, I don't think is bad. Now, if you're seeing that it doesn't shoot as well for you, it's probably, what I think is being a little weaker can possibly be a little more forgiving when something isn't quite right. Something's creating some forces on your arrow that would make it bend. And, if we want to get into that kind of detail, I mean, there's gravity holding it down. There's your rest pushing it up. So there's some forces on your arrow that way. And then as your string moves forward, the cable guard being offset creates some amount of flex on your bow. So your nock travel isn't going to be perfectly straight in line. It's going to go, there's going to be a little bit of right left. So those movements, those little forces, along with that high force, in line with the shaft, can create some flex to the arrow. And depending on, let's say your rest is a little bit, right or left, up or down, or where it should be, you can have some side load there. So, I mean, long story short, I think a stiff arrow could bring out some bow setup issues, more or less, more than one that's a little more flexible. And I think that's what you might see if you find that a 300 spine is shooting broadheads better for you than a 250 spine. Yeah, maybe that's being a little more forgiving for you, and it'd be okay. I don't think I would still not pick something that the spine chart show is too flexible, because I think that excessive flexing is going to hurt you. It's going to be more drag. It's going to be, not as tight, not as good at accuracy, and that momentum's not in the straight line when it hits the animal.
Yeah. Some of the points that you made in your answer there made me think of, maybe a natural transition to spin up. When I think about my finger release, if I'm shooting a recurve, and like this is one of my target arrows, if I shoot this thing in slow motion, I mean, it's doing this for a long time going down range. And I compare that to my hunting arrow that's got much higher profile feathers on it. It'll still have that same amount of flex coming off the bow, because that's, dictated by the S path for my finger release, but it stops that oscillation, that rotating oscillation, much faster. I think because this thing spins crazy fast in comparison. But maybe with a compound, there's not enough flex there to really be as relevant. I guess maybe explain the purpose and importance of arrow spin and how fast you want that or don't want it.
Yeah, spin to me is just really kind of averaging out any asymmetries. If your arrow's not straight, there's a little bit of curvature to the arrow, and it doesn't spin. So a little curvature to the arrow, let's say your point, let's say you're using a half out and it's not quite straight anymore, and your point is a little bit pointing right. If your arrow doesn't spin, that pressure difference across your arrowhead is just going to push it right. And if it doesn't spin, it's just going to keep pushing it right all the way down range. Whereas if it's rotating, you can see that it might open up your groups, but it's going to keep you still, on average, hitting the bullseye. Your groups might open up if your arrow's not quite as straight, if your point's not quite on the axis of the rotation, but it's not going to veer off a long ways. So that's primarily what the spin is doing for you. it's not really spinning fast enough to do much for stability, not like a bullet. Also, I've heard a few people out there talk about spin drift, and I probably shouldn't bring that up because people will dig into what that means. That happens with bullets that are going, I don't know, 400,000 RPM or something. It doesn't happen with It doesn't happen with arrows, and even though some pros are talking about it these days, it's really to average out asymmetry. The flexing, I'm not sure if it really does much to reduce the flexing either, because I've seen, videos of really extreme FOC with underspined arrows where that flexing is continuing, even though there's a pretty good amount of rotation in the arrow. But yeah, that's really what it's for. It does improve accuracy. In talking with Dr. James Parks, he did a study with target archery, and he said going from a 1 degree from a 0 degree, it definitely improved accuracy across all his testing. So that's just averaging out any little asymmetries there is with a target point in a shaft that's already very straight. These are often aluminum core, the best arrows made for spine and straightness, and yet he saw that spinning was important to improve accuracy. I think for target archery, a degree or so is fine. Say 1 to 2 degree. I do think that I recommend 2 to 3 degrees, and I've tested both of those quite extensively, 2, 2.5, 3. That's kind of the range I recommend for broadheads. I don't see really much improvement in accuracy, say from going from 2 to 2.5 up to say 3 or 6. I'm not really seeing much improvement in accuracy, but as you go up as high as say 6, you're adding more drag there. So anyway, that's also the negative of that spin up is when it first comes out of your bow, it creates a higher drag because those vanes they're adding some surface area that the oncoming wind is hitting. It's just kind of an initial spin up, but there's this higher drag force slowing down your arrow until it spins up. Once it's at speed, it doesn't add a lot, I don't think, because that arrow is the wind is relatively speaking is spiraling around the arrow, relative to the arrow shaft. So it's almost kind of in line with the helical vanes, at that point. Maybe a slight difference from straight, but it's pretty small. But it's that initial spin up that creates it. So having to spin up higher will give more drag and more drop. It'll slow it down more, a little more drop at distance. So to me, that 2 to 3 degrees works well. And I can tell you that, there's a Vane out there that we just did a video saying we're the most accurate, stabilize the fastest because we spin up the fastest. I would agree that they might spin up the fastest, but it's almost the same as other ones. I mean, they're all like, in the testing we did, it's all like, 70 to 80 revolutions per second with a bunch of different vanes. It matters more on the angle, in the height. But if you're talking vanes that are all say 0.45 to 0.58 inch high, you get a pretty similar spin up and rotation. And one that spins up, 1/100th of a second faster than another, does that mean it stabilizes more? No, I don't think it does.
Okay. And is that change from the target archery 1 degree to the bow hunting 2 to 3 degree primarily from the extra components and broadheads that we have in the front of our arrows versus just a glue-in, low-profile, perfectly machined target point?
Yeah, it is. I think, with that target point, there's kind of minimal lift going on at the front of that arrow. There's minimal stuff happening to push it off course, anyway. But with the broadhead, there's just more lift to it, so it's more sensitive. And so, I think if they get a few spins in 20 yards, they're probably happy with target archery. And what I like to see is what was I seeing? A couple of spin, a spin like within the length of an arrow. I think is probably more. It's probably more appropriate when a broadhead is on the front to just minimize any deviation as you're going down range. But now, do you need to spin 10 times in the length of an arrow? I don't think so. But I will say that's my opinion, but it's based on some accuracy data and some spin up data I've seen. so far.
Okay. And like a lot of people have seen, if you match your natural rotation or not, it spins up slightly faster as well. Do you think that's worth it for most people, or do you think that practically speaking, people shouldn't put too much effort into making sure that their vanes are spun one way versus another?
I think it's a pretty minor factor. I wouldn't talk people out of it if they want to do it. I could tell you that the results I saw 12 years ago when I first heard about it, the results I saw like a few weeks ago setting up a new bow were kind of similar. What I saw is about a quarter inch of counterclockwise, or a quarter of a rotation counterclockwise at 12 feet. But when I put 3 hybrid hunter vanes on it, about 2.5 degrees helical. Actually, this was 2 degrees. I think I was testing. As short as I could shoot the arrow out of my bow, which is about 3 feet, and have it hit the target, it was already rotating right. So I've seen some videos where they're showing more knuckleballing, especially with crossbows. But in my personal experience, the math there is just sum of the torques equals I alpha, or equals the moment of inertia times angular acceleration. And you've got such a high torque from those 3 vanes when they hit that airflow at 285 feet per second or whatever. Such a high torque right. That little bit of rotation left coming off the string is very quickly corrected right. That's been my personal observations, through high-speed video, through testing. But again, people could argue, well, yeah, but why do you want it to? Why would you want it to go that way at all and correct and go right? Yeah, I mean, in theory, it seems like it'd be better. In practice, I don't think it's that. I don't think it's a big factor. I think there's a lot of other things that are more important.
Yeah.
That should be down there. And I've done these other 20 things to make me a better shooter. Now I want to dig into these other little things.
Yeah, it seems like we, as archers and hunters, like to talk the most about the things that make very little difference, instead of the 3 and 5 things that make the most impact.
Yeah, John Dudley did a video on this not too long ago. He had arrows fletched it right and left, and I forget what all he had, but he was shooting groups at 60 or 80 yards, and the groups were all very similar, with a right versus a left helical. Yeah, so that's what I would tell people. Go shoot groups and tell me what you see. I would tell you that I've talked to some pros that said once Levi said you should do it, everybody started doing it. But the people that I asked said that they're not seeing any better accuracy. They just, if the best shooter's doing it, they don't want to take a chance that it's not actually better. So
yeah, I can tell you what I've seen, I guess, in my own slow motion testing has been that if I had, let's say, a smaller vane and it was fletched, let's say my bow naturally wants to go left, and I have a vane like this, 3 fletch, 1 degree right, just barely there, and I have a big broadhead on the front, then I would see in a lot of cases it would come out and just kind of stall for a little bit, maybe even, rotate to the right a little bit before it corrects and goes the other direction. Whereas in a lot of cases, that vane was also doing some weird stuff, like it was just understabilized. But if I put enough stabilization on the back, let's say like a 3 degree taller profile vane, then it was not different enough impact wise for me to tell a difference. Did the correct rotation, so to speak, stabilize and spin a little bit faster? Yeah. But to your point, I don't know that I could measure the difference if I wasn't looking at it with a high speed camera.
Yeah, that's a good point. A lot of my testing has been with higher profile vanes. So people with lower profile vane trying to shoot broadheads, that could be more of a factor.
Okay. Drag though, you brought up, and maybe that's a good point for us to again make some definitions. Drag is not drag, or maybe a better way to say it, there's more than one component to drag that people need to be aware of. And something that you had in the study papers that I thought was interesting is, you have your, what you call a profile drag, right? If you look down the arrow, how much air is being displaced. But then there's also the surface area of everything that's slicing through the air. And from the testing you did, it looked like the surface area of everything that's going through the air comparatively had more of an influence than the actual profile when looking from front to back.
Yeah, it does. The profile drag, if the formulas for drag, it's that frontal area times bunch of variables there. But so that profile drag is like, yeah, that whatever that shape is, that's, if you took a section and looked at it, that's what the incoming air is, got that direct pressure into it. And yeah, so with an arrow, thinner vanes should be, in theory, have less drag than thicker vanes, things like that, if you're looking at profile drag. But it's the viscous drag. It's that kind of friction from that fluid flow, that airflow across all those surfaces that make up a bigger part of the total force that's slowing down your arrow.
Okay. So if somebody was worried about drag, they say, hey, I want to choose a small vane or a lower profile vane or a thinner vane or XYZ to try and reduce that drag and then by extension improve their wind performance, would they be better off just by downsizing an arrow shaft and maybe going as short as possible?
Yeah, they would. The arrow shaft, and we did some modeling on this as well, from what I would call a small to a micro, or from like a 204 or 5mm arrow down to a 4mm or 0.165, 166 arrow. The modeling showed about a 5% reduction in drag. That's with the broadhead on the front. That's with the same vane being used, same knock, but just changing that arrow diameter, about 5%. And I could say from my own testing, shooting at 100 yards in a crosswind, it's hard to get a constant crosswind, but I would have put it in that 5 to 10% range also, myself personally. Like if I'm getting enough wind to where I'm having 10 inches of wind drift with a 4mm, I'd have 11 inches with 10 inches with a micro or 4mm, I'd have 11 inches with a 5mm or a small. It's not a lot, but for guys that are going for every little bit they can get, yeah, micros would give you some benefit there.
Okay. And I guess would the math say that in terms of wind performance anyway, does 5% of drag difference equal 5% of wind drift?
Pretty close. There's, Dr. James Parks did a study saying that, this initial, when the arrow comes out of the bow, there's kind of this initial kick from the wind, because you're at some kind of angle of attack really to that resultant wind velocity. So there's a kind of a kick of the arrow, and then it aligns with the airflow, and then you just have directly that drag is just directly giving you the drop, and that inline drag accounts for about 85% of the total wind drift, is what he found in his study. So yeah, if you use that, you say, roughly, if it's 5% less drag, it should give you about 5% less wind drift. You can also test this yourself, which is kind of what I've done, is just put a horizontal line out there on your target at whatever distance you feel comfortable you can shoot to, 60, 80, 100. And if you want to test different vane setups, just look at how much drop you're going to get with this different vane. If you're getting, 10% more drop with one, with a 4-vane setup over a 3-vane setup, your wind drift should be about 10% more too. So, yeah, I think at one time I had a misconception that it was more side surface area that was going to create the problem, but as I, put more thought into it and, thought through the rocket science here with that, once it aligns in line, it's just that inline drag. So it's easy enough for people to just test. We do it with a lab radar where we get velocity, but you can also just, shoot enough times to take out the error of your ability to hold on that horizontal line. But you should see some trends there. I certainly do, with one vane setup versus another. I'll see some group with one vane and a lower group with one that's maybe a 4-vane setup, or a lot longer vane. But yeah, that's going to give you more drag, some more drop at distance, but also more wind drift.
Yeah, that concept, the same as you, I used to think incorrectly that, oh, you just calculate the cross-sectional area and then just do the kinematic equations and you're going to find your wind drift. It doesn't really work like that. The thing that I guess made it more clear for me to visualize is just look up a video of an airplane landing in a crosswind and they're coming in, down that runway, kind of kicked off sideways. That was kind of a nice little visual for me to understand how that resultant airflow actually worked. If you tell people that, yeah, your drift is, your arrow's only seeing air going directly down the length of it, it doesn't intuitively make sense. You think it should be coming from the side, but
yeah. And I mean, even with engineers, because we're taught to do free body diagrams and draw the forces and X and Y components and analyze things that way. But yeah, it took a little more thinking of, oh, what's really happening with this arrow as it moves downrange. So I agree. It's not intuitively obvious, but I think it's important for people to understand that as well, because it's not necessarily the cross-sectional area. And this drag isn't necessarily just height and cross-sectional area. There's features on the front and back of the vane that I'm seeing create more drag than others. So it's complicated.
Yeah, so something like turbulence, for instance, I mean, is a broadhead design that has more turbulence. I mean, I imagine that would directly impact the viscous forces along the arrow and cause a lot of difference in noise and drag, probably, right?
Yeah, and I think there's some broadheads out there that have a lot of drag on the front of the broadhead, and whether it's going straight or at some angle, and I've tried to design our broadheads to have minimal drag on the front, and because as it's tipped to kind of minimize, if there's a slight tip to kind of minimize what that force might be. There's some out there that are just designed to be like a snowplow going through stuff, and to me, that high pressure on the front, especially if there's some angle to it, you can see how that's going to make it not fly as well at distance. So. Yeah, I think that's a flaw in some broadheads is there's really high drag over that broadhead. And it's creating, often more sound, more drop, and inaccuracy there as well.
Would you say for the most part, it's, if you look at a broadhead design, it's somewhat intuitive to be able to look at one and say, this one seems like it would cause a lot of turbulence, this one would not? Or is it sometimes, I guess, surprising what is actual and what is thought?
It usually goes along with, I guess if you've done fluid dynamic modeling enough, it kind of goes along with what you would envision from it. I don't know if everybody thinks that way, but if you've got, so we have bevels on the back of the blades for iron wheel, and so that that airflow that separates over the blade, and it's more easily comes back together. If you've got square back ends of it, it creates these little eddies, little turbulence. So that creates a higher pressure across it, because you got that higher pressure hitting the front of it and lower pressure on the back with those little eddies going on there, rather than having it more uniform there. So yeah, often if you see something that's more square back to the back of it, or a big step down, you can kind of visually see it where there might be issues. And I can tell you, we did like a blind sound test at one hunting camp I was at, and shot a bunch of different broadheads. And surprisingly, the one that was the loudest wasn't vented. It just had some, the back of the blade. It was a three blade, one piece, like monolithic, but the back of the blades were square, and then there were some steps also in that kind of ferrule. And it was just creating a buzz for whatever reason, just the turbulence coming off of there. But I also think it probably had a very high drag to it.
Yeah. Is it, I remember a little bit back from the college days of laminar versus turbulent, and laminar, you always think of those nice, smooth charts and diagrams as compared to turbulence, where obviously you got all the eddies and swirls. With aero speeds, we're pretty much always talking about some type of turbulence and just a matter of how much.
Yeah, I think so. In general, well, I don't know. I mean, the modeling would say that there's some place where it stays laminar and flows over it, but there's often some turbulence happening as well. And I think, one thing I see is that whatever's happening at the broadhead and the veins are pretty much separate. People ask about, should I line up my veins with my broadhead? I don't think it matters about lining them up, because that air is back to kind of laminar flow along the shaft before it hits the veins. Typically, no, that's with our broadheads. Maybe there's some that there's just such a turbulence off of them that it affects the veins more.
Okay. Yeah. So when I think about other industries, examples of where, drag is important, I think about obviously like car and plate designs, but also you think about weird things like golf balls. It's like, well, golf balls have dimples because it changes, where that flow separation occurs. Is there potentially anything there from either an aero, surface or broadhead surface design that could benefit us?
Yeah, good question. We had that same thought there, and I could tell you we haven't really seen a difference with, we've tested some kind of ribbed designs, and as well as smooth, as well as some more textured. If we're using the same profile, we're not seeing really much difference in velocity at distance. So while there could be something there, we haven't found it to be a big factor at this point. We haven't done dimples exactly. I mean, we modeled that up, but for what we've seen so far, I don't know if there's anything there. If someone wants to try it, go for it.
Okay. And even like your vein profile, it's got a texture to it. It goes, if you look at down the length, it's got ribs that go in and out.
Yeah.
I would imagine, so it's increasing your surface area, so slightly more viscous, maybe marginally so, right? Is there any other big reasons to have that surface texturing and that vein profile?
Really we went with this because of the material. This material, which we got material from AAE. We've got it from Boning, Q2I supplied material. So I tried to talk to all at ATA. I tried to talk to all the vein manufacturers and get material for testing. We got it from a number of them. In last year's study, the hybrid material we got had these ribs in it, so we couldn't really test the hybrid material without the ribs, because the way we were making these we were laser cutting these profiles out of ribbon material. So this performed a little better than Max Hunter for a little bit less drag, a little bit less sound, a little bit less wind drip. But we couldn't say for sure if that was the slightly more flex to the vein or it was the ribbing. But we know the combination worked the best, and that's why we used it. I could tell you that as we're testing, I'm testing some new profiles right now that they have kind of the same accuracy, stability, but now I'm looking at, can we reduce sound? Can we reduce drift by front and back geometries really? And we were just testing this morning actually. We had all the engineers up here, and I was doing offhand long range shooting to look at velocities. And so far it's been hard to see a difference between ribbed or no ribbed, textured versus super smooth. So I thought there'd be something more there, but I'm not. It's within the variability I think we're seeing from shot to shot. So we haven't picked anything out there. I do think it's also because these veins are at some angle. It's not exactly like it would be if you're just shooting straight veins either. I think it's more complex in what's happening with that airflow across that surface because it's at some helical and rotating.
Okay. So at the end of the day, it still sounds like the biggest influence on vein design from a stability standpoint, restoring torque standpoint, is the height as much as anything else.
Height, but also the profile, the kind of the geometry. And what I would say from last year's study, we saw that having it having the area kind of higher and further back, and it makes sense. That's going to move the center of pressure on that vane back. So it's going to move the, center of pressure on the overall arrow back. So you've got more restoring torque with that.
Okay.
And so, like, for instance, the hybrid, the hybrid profile, which is more parabolic shape. And I'll just mention AAEs because they make both of these profiles here, versus the Hunter profile, where it's you can see that it's taller. It continues to get taller all the way to the back, and has a more kind of abrupt drop from that. So we see more restoring torque from the Hunter profile versus that more parabolic. This is the hybrid 2.3 or the stealth profile. But there's lots of kind of parabolic profiles out there, and especially in the target world, I think those are kind of preferred because you can get a little less drag. Although with these two vanes, because it's longer, the drag is really very similar. So in this case, you're just getting the same drag, maybe even slightly more, but not quite as much restoring torque to it. It is a little quieter though. It's one of the quietest vanes that we tested.
Okay. So if you were to rank your priorities, if you're a bow hunter and you're going to be shooting a fixed blade broadhead, and maybe tackle it, if the answer is different, tackle it from the Western mentality versus like a whitetail 30 and in, what are you doing to choose your exact vane setup, and how does the study results play into that?
Yeah, for me on, just this vane design, exactly. I mean, accuracy is number one by far. Am I going to be able to shoot broadheads well at long range? Is it going to be forgiving? If my bow isn't perfectly tuned, or, maybe it wasn't tuned a month ago, but the little string stretch, little cam creep, or little, not cams, but limbs can creep a little bit. Your tune can change a bit over time. Or, just, rain for 4 days and you're out in the mountains, and just, I don't know if getting your string wet is supposed to change your tune, but I feel like there's sometimes it has for me slightly. But let's say your bow's now a little out of tune. You're shooting up or down at some angle, so your form's not perfect, and you're maybe applying a little more torque. So, and your tune completely depends on your personal form, where you're pushing, where your pressure is on that grip. I can see that I can tune a bow perfectly for myself, put it on a shooting machine, and we got to retune it completely because the grip pressure is different, So you can see how your tune is going to change a little bit if you're shooting up high angle, low angle. So I want a vane that's very forgiving. That even if the arrow's a little bit tail left, tail right, up, down, come out of my bow, it quickly straightens it out and it's going to hit right when I'm aiming anyway. So that's a big number one for me. Second for me is drag, because it also equates to wind drift. So drag, drop, wind drift. I don't want to give up any more speed than I need to. I want to maintain that momentum. If for a bow hunter, you want to hit where you're aiming, number one, and then you want to penetrate as well as possible. Number two, with as big a cut as you can get to work for you, really, or get to work accurately at that range. So, so that drag is number two. I don't want to give up any more velocity, any more momentum, which is mass times velocity downrange, because that momentum is going to give you that force. That's probably the most direct measurement of how much force is your arrow going to have to drive through that animal. It's that momentum impact. So I want to maintain that mass velocity downrange. So yeah, the number two for me then is drag, because as I said, that often also equates to wind drift. It's rare that I get a shot in the mountains. Well, sometimes where there's zero wind, but 5 to 10 is pretty common. I want an arrow that isn't going to drift very much at long range with 5 mile an hour wind, say. So, and then number third for me is going to be sound, and that it's probably it's not that big of a factor for me. It's like if I had two vanes that were both equally accurate, one was quieter, I'd pick the quieter one. But if I have a vane that's a little bit quieter but not as accurate, I wouldn't pick the quieter one. Me personally, those would be my choices for long range. And I do a lot of whitetail hunting too. I hunted whitetail in I think 4 states last year, and I grew up whitetail hunting in Wisconsin until I moved to Colorado 25 years ago, and then kind of focused more on big game, Western big game. Elk, mule deer, antelope, bears, goats, and sheep this year. I drew a sheep tag this year. So
Nice.
yeah. So my thinking for whitetails, it's not going to matter as much for whitetails. My shots are almost always under 40, very commonly under 30. I try not to really have a setup where I'm going to have to shoot more than 30. I'd prefer 20 on whitetails. And the reason I say this is because they move. You can, and I go on doe patrol in Texas where they're hunted a lot and they're pretty keyed up, and trying to shoot a doe at 35 yards is tough. If you, you can I aim at the bottom of the heart and you can usually do okay. But if I forget and aim a third of the way up, I've had them duck it at 35 yards. So anyway, the shots are often closer. Drag isn't going to matter that much to me. 4 vanes versus 3. 4 vanes shoots better for you. Go for it. The velocity difference at that short distance is not going to matter a whole lot. A heavier arrow would be okay too. With increasing mass, you can get a little more penetration. I don't care if it's a bit heavier and a bit more drag because my shots are going to be closer. So, what would that mean for vane? I'd want to for sure have a vane tall enough to stabilize that broadhead because, for me, that's still going to be key. I might be shooting a wider head there. I might shoot our wide series broadheads. And I often do at bear, at deer, pigs, things where I'm kind of set up to get a closer shot. Why not go wider? They're going to penetrate great, but you need more stabilizing. So 3 high profile vanes works well. And this is where people will argue that noise might matter more for a whitetail. Well, I agree they can react more than say an elk or mule deer or a lot of the Western big game. But also if you look at that, and I've looked at a lot of these traces, this bow noise, if a deer's at 20, the bow noise is way louder than the vane noise later, when it's say 10 yards from the animal. So you get a high bow noise, and then you get this ringing from the bow when the arrow's 10 yards down range. And then it starts getting quieter, and then it flares up just as it's hitting the animal. So this is my personal opinion based on shooting a lot of whitetails on video and from looking at the sound testing. I don't think the vane noise is the problem. I think they hear the bow go off, and either they're so keyed up, a lot of times does are like, any noise, I'm out of here anyway. Or they hear the bow going off and they maybe start ducking and look your way, and then they see some movement. Their vision is very keyed on movement. So, man, I shot it's interesting. I hunted does this year where I was testing a new head, and I shot one, and I aimed a third of the way up. I was still kind of in elk mode. I aimed like a third or halfway up the animal. The doe took the shot. She ducked it completely. It was like 30 yards or something like that. I'm like, oh yeah, I forgot. I got to aim lower with these Texas whitetails here. So the next deer that comes out, her head was partly covered, and she was standing up with her head up. And I shot at her, and so I aimed at the bottom of her. I aimed to cut hair on her brisket, basically, thinking she was going to drop into the arrow. She didn't move at all. I cut hair on her brisket. She couldn't see me, for one. Also, with her head behind something, she maybe couldn't key in on where that sound was quite coming from as much either. But to me, that kind of said there's some visual thing going on maybe too. Like they very quickly have their eyes in that direction, and then they see you move, or maybe they see the arrow coming, they see the bow motion. So I want to do more experimenting, but I'm just trying to give you some of the evidence why I've kind of concluded on white, those close shots, I think it's quieting your bow is important. But I don't really think that the vane noise differences, which are relatively small in the plots I see, I don't think that's causing one deer to duck your arrow and another where it wouldn't if you had a different vane on there.
Yeah, no, that's really great insight. I've seen in similar scenarios, sometimes you have one deer duck the arrow, one deer does not, and it seems like everything is the same. Or maybe in a scenario in which you would expect them to drop because it's pin drop quiet, maybe they had gotten spooked earlier in the encounter slightly, and then they don't react at all. And then you have some other early season, cicadas are buzzing, and you're like, oh, there's no way the deer's going to react, and they completely flip out. There's so much variation, it seems like.
And I exactly had that situation. Shot over one. I shot under two because I tried that twice with another doe whose head wasn't covered by something and also didn't duck. So, then I decided, well, I got to just aim at the heart, and then I started killing some deer after that. But you're right. I think a lot of these deer, with the sound of the bow, it's already in them to move or not move. Yeah, but I think, but a lot of guys will show some video where the deer didn't move immediately, but then moved a little bit later. Well, it takes a little while for your sound of your bow to get there, for one. But also maybe there is a visual thing, like, yeah, the head tipped is looking towards you, and now they're ducking. Again, I want to study it some more, but those are my thoughts right now.
Yeah. I know I've had a number of people message me and say, hey, look into lighted nocks. And I'm like, can you even see a lighted knock from the front? Maybe you can. Maybe with their eyes, collecting more light relative to ours, maybe it doesn't seem like much to us, but maybe they see a faint glow coming from, kind of a halo around the arrow with their vision. That might be something to look into as well.
Yeah. I didn't hunt with lighted nocks for for years because I was worried about that same thing. And also a lot of them, with the plungers and things in there, a lot of them aren't that solid of a knock, and they flex a bit too much, I think. And I'd see my groups open up at long range. So often I wouldn't use them for Western big game anyway. I might use them for whitetails, but often I didn't also because I was worried about that. But at this point, the thing I like about lighted nocks is I've used them pretty extensively the last few years, and every time I took a shot with one, I knew right where I hit. And also, if you're videoing the hunt, which I'm doing more of to see, results of broadheads, it's nice on the camera when you can see the arrow go through the animal on a camera too. So those are the two reasons why I often use them a lot. But like you said, it's so hard. No two animals react the same. So you'd have to shoot a bunch with lighted nocks and a bunch without to really very similar setups to really try and determine if it matters.
Yeah. It's like, number one, you could probably prove if you can see it or not, if you can see the glow. And then even if the answer is yes, then it's just like with sound, there's so much variation but at least if you say, no, we can't see the light from the front, then it's probably not a big influencing factor.
Yeah. And it probably depends on how dark it is, right? I think, I'll hunt pigs at night in Texas. We'll hunt them in the evening, and then we can go into the night. And I can tell you when it's dark, they for sure can see that light coming because everybody around can see it. It looks like a laser beam, flying out there at whatever angle. I think even from the front you could probably see it. But in like legal hunting hours in in every other state, I would say it probably depends on how close it is to last light. But at last light, maybe it could pick up. It's probably worth doing with a camera system and just seeing it. At low light, how visible are they?
Yeah. Well, I know with like some of my better cameras that are able to see, they're really sensitive, and I might shoot an arrow at a target, and then the camera's set up so that it sees brighter than I can see, and I see the lighted knock the way my eyes perceive it in a low light environment, and then I look at the camera and it's like the whole thing is just glowing red around, like way more than I would perceive myself when we think about animals seeing. Granted, there may be more rod heavy than cone heavy from a color perspective, but yeah, anyway, there's some interesting stuff there.
Right. And yeah, and animals don't see red light as well, I think, red and green. So yeah, those are typically the lighted knot colors as well. One thing that we didn't touch on that a lot of people probably ask, or I've gotten this question a few times, is what about vein stiffness, and are you testing that? And how much does that matter? Some of the newer veins coming out are very stiff, thinner, very stiff. In theory, I'd say thinner should reduce that drag somewhat, that profile drag at least. In my testing so far, I haven't seen a thinner vein really have much less drag than a slightly thicker. It seems to be more that geometry along with that angle. We just did more testing on this today with some different thickness of veins, and I'm going to need to crunch the data. But just as I was looking at it off the lab radar, I don't think I'm going to see a difference in. We were looking at velocity at 20 yards versus 80 and what that delta was with different profiles and thicknesses. I'm not really picking it up. But I want to do more testing there. It seems like in theory there could be something to that. Yeah, but that profile, that thickness, I don't think it quite works that way for whatever reason. An arrow when it's rotating, that reducing that width there isn't like a 1-to-1 with the amount of drag that I'm seeing at this point.
Yeah, interesting. Maybe it's also, like I pointed out this vein earlier as being a really soft material. And even at recurve speeds in slow motion, I can see this fluttering at 200 feet a second. And, maybe there's a point of diminishing returns where it's like, as long as it's sufficiently stiff to not flutter, then making it stiffer doesn't have a, same magnitude of benefit.
That's what seemed to be the case in the hybrid profile. When we had the very flexible material that was fluttering, we had a lot more drop too. So that fluttering was adding drag and drop. But the hybrid material did slightly better than the max material, and even though it's a little more flexible. So I was trying to figure out, why is that? I think probably when it first comes out of the bow and all that pressure's on the veins, having them be able to flex a little bit probably reduces the drag force there. So a little bit of flex probably reduces that drag. I think we saw maybe a slight improvement in accuracy, but it was close. And I think maybe having a little bit of flex, if it's having a little flex can reduce the pressure on it. And so I could see how that could have a little bit less force. It's probably for some short duration, but a little less force there, and sound as well. A little bit lower pressure if they're flexing. Maybe that's an improvement over that higher pressure if it's rigid as that air comes off of it. That's speculation, but it does seem like maybe there's a sweet spot with stiffness, and more flexible isn't necessarily bad until you get to the point where there's fluttering happening. And that also seems to depend on height and geometry as well. So I don't think there's one best material for all either, or one perfect stiffness for all, because I think it's also going to vary by that height and the profile and, the pressure profile on there.
Yeah, no, that makes perfect sense. Well, I know that this was primarily focused on the vane and, restoring torque, choosing the right vane for your hunting setup, but you do own a broadhead company as well. So what would you say are the most commonly recommended from you broadheads out of your lineup for either the Western guy or the whitetail guy?
Yeah, for Western, I'm generally recommending kind of our standard size heads, our S series, which is our solid blade. We originally just had our V series, it's a vented. Then we had our S series, which is very similar geometry, just a solid blade. And the vented was just to get the weight down at that 100 grain point. But our solid blade is a good choice. Our S series for kind of an all around, but if you could do some Western big game like elk hunting, there's probably been more elk killed with that head. Or S100, S125 are very common there. In the last couple of years, we came out with our single bevel. It's really the same blade blank that we just grind differently. Just grind one side or both sides. the flight has been very similar there. In the modeling, I see there's a little bit of torque on the arrow, but very little compared to the Vanes. And so I see they fly the same at long range. They're both great long range for long range flight. Very durable. People are using those same exact heads for Cape Buffalo and getting pass throughs. A lot of people are hunting those right now and giving me some results there. Often we'll say without the bleeder for Cape Buffalo, but I think anything in North America, elk, moose, whatever. If you've got a lighter setup, maybe if you got a very light setup, maybe you want to remove the bleeders, just have one main blade that has to, cut through if you hit scapula, whatever. But I'd say for most, average bow hunter bow setups, the bleeders kind of provide minimal additional drag through the animal, but they open up holes better and give better blood trails in general. So yeah, our S series or single bevel is kind of my Western big game setup recommendation. They work great for everything too. If you want to have one head to shoot, whitetails on up, and if you just don't want a really wide head either, then I suggest our S series or single bevel. And we can go into what's the difference between those two, but they both perform really good. We then have our wide series. So it's 1 3/8 wide main blade, 3/4 inch wide bleeder. So a 2 1/8 inch total cut. What we're trying to do there is get kind of the same total cut as a lot of mechanicals out there, but give you the added benefit of if you hit scapula, spine, different, if you got some shot angle that's, frontal, slight quartering to, whatever, that it's going to give you your best chance of penetrating through hide bone tissue. With our steel, the high hardness and edge retention, and that impact strength, it'll cut through, bone hide tissue like no other, get you more penetration. And we really see with a wide head, it has minimal reduction in penetration. So I've used those a lot for whitetails and bears, and even elk when my setup is where I know I'm going to get a closer shot. I've gone through an elk, including the offside scapula, and then buried into a soft log, but a log 10 inches on the other side of it. So, I mean, the whites penetrate great, but they're going to be less forgiving in long range flight. And I'm seeing that in university testing too. We'll test field points, then our S series, and our single bevel, 125. 100s are even a little bit more forgiving, but our 125 is a very forgiving head. And they'll test our wide vented and our wide solid. And I could tell you that the wide vented is a little less forgiving than the S series or single bevel, and the wide solids even less forgiving than that. So I wouldn't shoot our wide solid heads. If I planted to shoot 60 and over, I wouldn't pick that head to do it. You can shoot it well, but you just have to have less, your arrow needs to be coming straight out of the bow or your groups are going to open up. So anyway, I think they're great choices though for whitetails, just for those closer shots, but you need to have enough Vane for them. If you're going to shoot the wide head, shoot a Vane that's 0.55, 0.58 inch high. And if your bow relatively well tuned, it doesn't have to be perfect. And what I'd consider, it can be even fairly out of tune. But the closer you are to being in tune, the better off you're going to be. It's just less fishtailing of the arrow. You maintain momentum better. So, yeah, I'll bring that up too. If you shoot mechanicals because you can't get fixed blades to shoot well, you're just covering up some issues that are covering up problems that are still problems for you. You might hit closer, but if your problems are due to being underspined, excessive flexing, that's going to hurt you on penetration. If it's because you got excessive fishtailing because you're not tuned, that's also going to really hurt you on penetration as well as slow your arrow weight down. So, yeah, you're better off fixing those issues and being properly spined, relatively well tuned, and having enough Vane on the back. You should fix those problems anyways. Even if you choose to use a mechanical for whatever reason, it's going to be a better bow hunting setup for you.
Perfect. Interesting. You laid out that progression. When I have tested your heads, that's from a forgiveness standpoint, that's pretty much what I had seen as well. Smaller heads than the wide vented, and then the wide solid being the requiring the most stability, bigger Vane.
Yeah, we just did some testing at the field house recently that we videoed, and we saw that these new vanes we're testing, as well as the hybrid hunter, even with that being 8 inches off out of tune at 40 yards, the best vanes there we're hitting within an inch of field points. But the with the wide solid, I was seeing 3 to 4 inches off at 40 yards. With this is a bow that's really out of tune, but you can see it. It's gonna hit off further for sure.
Okay. One question that maybe comes to mind now. I mean, all of this is a direct result of how much lift that broadhead is creating, like you talked about earlier in the podcast. With especially like the wide solid, you think about that as a big plane. Do you think that there's value in guys maybe not aligning their broadheads with their vanes per se, but aligning the broadhead plane consistently from arrow to arrow, so all the arrows in their quiver, dynamically are acting exactly the same and have the same lift characteristics as that arrow leaves the bow?
Yeah, good question. I think if your bow is well tuned, it has very little effect. In theory, having it aligned vertical would be the best in a compound bow, because your flex is typically vertical, and so if your flex continues for very much distance at all, there's going to be less angle attack to the blade if it's aligned vertical than if it was horizontal. If you're shooting a recurve, you should have it horizontal, because the flexing of the arrow there will be in plane with that blade and have less angle of attack with that blade. If you're properly spined to a little bit stiff, which is what I've tested, then vertical, horizontal, or at 45, they group the same, and I haven't really had to worry about it. If I'm doing a setup where it's easy to align, then I'll do them vertical. Otherwise, I won't really worry about it. If you're seeing a difference, though, and occasionally we get a customer that will say this, the broadheads shoot better aligned at some, at horizontal or vertical than ones that are the opposite of that. And what I tell them is it's probably just picking up some flaw. Your bow's a little out of tune that way, or your arrow's flexing that way, and it's amplifying some issue. And if you don't want to dig into that issue right now, I understand. Okay, just put them all the way that works best for you, which might be horizontal or vertical.
Okay. And then back to the recommendations with traditional, I would assume wides are just fine, and you recommend wides probably as much as small blades, or do you prefer any given blade design for a traditional guy?
Yeah, I would say that penetration's been great with standard and wide, and I know a number of traditional shooters that have used both quite a bit now. I was on a bear hunt where I saw a bear shot with a wide, and you could see in the video that arrow hardly slowed down going through a 350-pound bear. So I think penetration is good with either. It will be less, wides will be less forgiving, wide solid, but I think most trad shooters, they're not super accurate anyway. It's probably within their ability to shoot quite often. And I might get bashed for this, but I would say that a lot of good trad shooters I know do like the wide for bigger hole. I think the inaccuracy of trad is more of an issue than, I guess, just the inaccuracy in general is more of an issue than just having slightly higher groups, possibly with a wide versus a standard. In case they don't hit exactly where they're wanting, having a bigger cut to cut more is often preferred. But I don't know. I'd say it's probably an equal split of how many people are using standard versus wide, or maybe even more standard than the wide. But I shoot trad a lot. I don't hunt with it much at this point, so I'm not the best guy to ask. But I kind of recommend, they both work well. The wides might be a little less forgiving, but they give a bigger hole, and we have a lot of trad guys being very successful with both at this point. Yeah. Well, I know a couple of engineers talking probably got into the weeds more than others might, but I think it's good stuff for people that want to know this stuff in that kind of detail. They can read the reports. They're on our website, ironwalloutfitters.com. I put a video on our YouTube channel recently, just kind of summarizing the vane height, vane shape. For those that would rather, watch TV than read a book, they can go and watch that on Iron Will Outfitters YouTube channel. But yeah, hopefully some people listen to the podcast and can really dig into it. And then, feel free to send us questions. I answer questions daily on this stuff. And we've got Bailey in our tech support is great as well with help with arrow setups. But if she can't answer it, she passes it on to me. So I'll try and help you out.
Excellent.